Within a century, a new cosmic era begins. Long before the human race was aware, most of the universe was surprisingly small. Astronomers were of the opinion that everything in the Milky Way contained all of existence, but Hubble observed it. In 1928, shaking off this presumption with specific measurements that demonstrated that the universe was expanding rather than remaining static. The revelation was groundbreaking, providing an entirely new perspective on the universe. The Hubble Space Telescope, launched in 1997, made a remarkable discovery. The universe's expansion was not slowing down, as previously perceived, but accelerating due to an unknown force. This is what we now refer to as dark energy. A breakthrough in the estimation field determined that the universe is 13.8 billion years old. However, new information from the James Webb Space Telescope is causing a stir, challenging this timeline's foundation and possibly altering the regulations of the cosmos. There is a cosmos within the Milky Way, a cluster of stars known as M92, that baffled scientists. An extensive cluster of ancient stars is believed to be as old as the entire universe itself, 13.8 billion years, but some estimates suggest it could be even older. How can this be when the very idea seems absurd? It defies reason that stars existed before the universe as a whole. Despite this, the data from M92 challenges our fundamental beliefs about the universe. Using cutting-edge methods, astronomers modeled over 20,000 artificial populations of stars to determine the cluster's age. The result? An age so close to the universe's presumption that it brings up a baffling inquiry. Could we have been erroneous regarding the timeline of the universe? Enter the James Webb Space Telescope, the most advanced telescope instrument that mankind has ever targeted at the heavens. The Webb has observed the universe like never before, discovering galaxies that were only around for 300 million years following the Big Bang. But here's the problem. These galaxies are significantly more massive and advanced than they ought to be for their age. The universe may be older than we consider. The discovery of these apparently impossible galaxies and the paradox of M92 suggests that we might have to reconsider everything we thought we knew about the universe's age and development. This leads us to a daring new hypothesis. Suppose the universe does not date back 13.8 billion years. A daring idea comes from a recent study proposing an alternative of a 26.7 billion-year-old universe. This theory holds that our knowledge of the expansion of the universe and the beginnings of galaxies and stars could be insufficient or even fundamentally flawed by the enigmatic Methuselah stars that appear to defy time and mature galaxies discovered by Webb. The evidence supports a single conclusion. We may be on the verge of a scientific revolution. But this goes beyond just numbers for the universe's chronological order. What implications does this have for our comprehension of the nature of life and its secrets? The truth can be found in the billions of years we have overlooked and concealed. One of the cosmic neighborhood's most puzzling mysteries is the Methuselah star, formerly known as HD 14283. It is thought to be nearly 14.5 billion years old, older than the universe itself based on current models. Can this be true? Stars' life cycles exhaust their fuel at rates dependent on their size, yet Methuselah defies these rules, aging at a slower rate. The Methuselah star is the center of the universe, a beacon rather than just an anomaly, pointing to more in-depth inquiries regarding the beginnings and limits of our universe and human understanding. At the heart of this debate is one important value, the Hubble constant. This number, the rate of expansion of the universe, is a key component of cosmology. But there is a problem. The Hubble constant refuses to settle on a single value. Early measurements using information from cosmic background microwaves suggest an expansion rate of 68 kilometres per megaparsec. However, measurements taken from nearby galaxies and stars indicate a rate closer to 73. This difference, known as the Hubble tension, has left scientists wondering whether we are unable to agree on the speed at which the universe is expanding. We can't accurately estimate its age if forces beyond the scope of our current knowledge of physics, such as dark energy or even unidentified forces, may be at work. One of the most innovative successes of the James Webb Space Telescope is its ability to observe the universe's dark ages prior to the birth of the first stars. Webb has discovered nothing less than astonishing. Galaxies identified just 300 million years after the Big Bang, with masses comparable to and organized similarly to the Milky Way galaxy. Based on the current schedule, these galaxies should not even exist, as they would have formed over billions of years. But the Webb keeps discovering more galaxies that defy explanation and bring about an intriguing query. Could the Big Bang model itself be incomplete? Growing evidence suggests that some parts of the universe may be older than 13.8 billion years. Scientists are even turning to a radical concept: the multiverse. If the universe is only one of many, each with its own physical laws and timeline, controversies like the Methuselah star or older galaxies might make total sense. The multiverse theory holds that the apparent contradictions of the universe may result from interactions with other dimensions. If this is correct, the James Webb Space Telescope could be giving us a look inside these realms adjacent to the multiverse. The results would extend far beyond astronomy's scope, putting into question the very foundations of reality as we see it. The James Webb Space Telescope makes us reconsider the timeline of the universe. Forgotten theories have begun to resurface, bringing back the idea of a cyclic universe. According to this theory, the universe has not been around for just 13.8 billion years, but has undergone numerous cycles of expansion and contraction, followed by big bangs and crunches. The ancient stars and galaxies observed by Webb may be the remains of an earlier cosmic cycle. If so, what clues could they provide about the universe that came before ours? A different puzzle solved by the James Webb Space Telescope involves the enigmatic existence of dense primordial black holes. These objects, believed to have formed moments following the Big Bang, may hold the key to comprehending the age and beginnings of the universe's evolution. The existence of black holes could explain the seemingly impossible galaxies observed by Webb, acting as gravitational anchors that sped up galaxy formation. However, their presence also creates a troubling inquiry. What else about the universe's early history are we missing? We know that dark energy is the missing piece, an unidentified force behind the accelerated universe's expansion, but could it also keep secrets regarding the actual age? Recent observations of the universe suggest it's possible that dark energy is not as constant as we once thought. It could be changing the speed with which the universe grows. Over time, the universe expands in ways that test our comprehension. If dark energy has altered the cosmos's time, it could account for the rapid development of galaxies and the contradiction in the timeline of the universe. Nevertheless, it also opens a Pandora's box of new inquiries. On the smallest of scales, the place in space and time where quantum mechanics regulates reality, and time itself appears to determine whether this holds the key to the James Webb Space Telescope's uncovering of mysteries. Quantum theories for the James Webb Space Telescope suggest that the universe's beginnings may have witnessed phenomena that we are unable to comprehend. Potential fluctuations changed or even created entire galaxies. The actual progression of time, from dilation to the quantum level close to black holes, challenges the fundamentals of the Big Bang. The James Webb Space Observatory's discoveries are forcing us to confront the most fundamental concerns regarding reality. The findings made by the James Webb Space Telescope have not only increased our observation of the universe, but also cast doubt on the very foundation of contemporary cosmology. From what appear to be ancient stars older than the entire universe, to galaxies with impossible masses formed in their early stages, evidence is mounting that the tale we have been telling about the universe may require revision. Rewriting the story is about more than just comprehending the age of the universe or its history. It is about a much larger issue, the unending mysteries waiting to be discovered and the enormous potential of human curiosity. What would happen if the universe isn't 13.8 billion years old? What if it is 26.7 billion years old, or even eternal? If the universe we live in is merely a chapter in one aspect of a grander multiverse epic, the James Webb Space Telescope is certainly more than just a machine. It is a time traveler that tells stories and holds the key to existence's secrets. With each image it sends back, it forces us to dream bigger, inquire about everything, and accept the unknown. Therefore, what do you believe? Are we stumbling across a cosmic abyss? As the James Webb Space Telescope, JWST, continues its revolutionary observations, it poses challenges to every aspect we believed we knew about the age of the universe. The discovery of galaxies that appear significantly older than their assumed age, and the unexpected results from ancient stars make the point. The universe might be significantly older than the usual 13.8 billion years. Some of JWST's surprising discoveries imply a universe that might have formed far earlier than we ever imagined. Using cutting-edge tools like JWST, astronomers have been able to observe the universe and locate galaxies that formed only 300 million years after the Big Bang. These galaxies have tremendous mass and are far more complicated than current models predict for galaxies of their age. This revelation raises the question, could the universe's timeline be inaccurate or at the very least incomplete? The discovery of ancient star clusters, like those found in the Milky Way, specifically the M92 cluster, has raised important eyebrows. Its stars are believed to be nearly as old as the universe as a whole, and the findings of some studies suggest they might even be older, challenging traditional star and galaxy formation models. If these stars had previously existed during the initial formation of galaxies, it would imply that the early universe had a different structure than previously thought. Additionally, scientists have long debated the rate at which the universe is expanding, known as the Hubble constant. Different estimates of this rate have only made the mystery more complex concerning the age of the universe. The more recent discoveries of galaxies and strange star formations could indicate that our estimates of expansion may have fundamental flaws, requiring scientists to rethink their complete comprehension of cosmic history. As astronomers keep analyzing the data from JWST, a radical new hypothesis is beginning to form. Some suggest that the universe might have gone through multiple cycles of expansion and contraction, a cyclic universe. From this point of view, the universe did not start with a huge explosion 13.8 billion years ago. It may have gone through numerous cycles of cosmic rebirths, each more complicated and distinct from the previous. These discoveries indicate that humanity is on the verge of rewriting the universe's history. Could we be close to discovering a cosmic history that is far older and more enigmatic than we ever imagined? The James Webb Space Telescope is only beginning to reveal the layers of the universe's darkest secrets. With each new discovery, we move closer to acquiring revolutionary insight into the universe.